the numerical ratio of displacement to the distance covered is always. Now, there is a theoretical question. So, for this question, there is a concept, as we know that whenever a particle moves along a straight line in one particular direction, like let us consider particle starts from point O and it is moving towards B from A to B. Now, the particle is moving on a straight line in one particular direction. When it reaches at point B, we have to find its distance as well as displacement. So, if we have to find the value of distance, so we can say distance is what? The path length. Let us consider the path length from A to B is S. And if we have to find the displacement, so displacement is what? The shortest distance, or how to represent the displacement with the help of a straight line vector from initial position to final position. So here initial position is A and final position is B. So we can represent the displacement with the help of straight line from A to B. Now this one is the displacement heading towards B. So displacement is a vector quantity. So the magnitude of displacement is S, just like distance, and the direction of displacement is from A to B. So here we can see the magnitude of displacement and distance both are same. So for the given situation, we can say the magnitude of displacement is equal to distance. But suppose if particle returns back from B on the same path, like the particle is, as we discussed before, the particle is at point B. If the particle returns back at point A, along the same path, so we have to find the value of distance. So if particle moves from A to B and then returns back at its initial position A, so we have to find the value of distance. Now distance is what? Path length. So initial distance is S, and finally when it moves from B to A, then again the distance is S. So the total distance is S plus S, which is equal to 2S. But displacement is, as you observed, the initial and final location of particle is same, starts from A and ends with A. So the displacement of particle is 0. Here we can see the total distance is 2S and the magnitude of displacement is 0. So the summary is, the result is, distance and magnitude of displacement both can be same, but the condition is particle is moving on a straight line in one particular direction. But when particle changes the direction, the value of distance is always greater to the magnitude of displacement. So the final relation in between displacement and magnitude of displacement and distance is, distance and magnitude of displacement can be equal, otherwise the value of distance is greater than displacement. So the correct representation is, the magnitude of displacement is always less than equal to the value of distance.